Hello, welcome to the video. This time we're looking at fractions of quantities, which is going to involve how to find fractions of things, equivalent fractions, simplifying fractions, and comparing fractions. So just basically the fundamentals of how to deal with fractions. So first of all, what we're going to look at is what a fraction actually is. Now, if I were to just draw a fraction, or at least a fraction line, we generally have a number on the top, which we call the numerator, and then a number on the bottom, which is called the denominator. Okay, so the numbers have specific meanings, and generally the denominator can be said that it's the total number of something. Total number of equal parts. Okay, and then the top part, the numerator, is how many of a specific type. Okay, so what does this mean? Well, it's much easier to put into an example. So what I'll do is just draw a series of dots, okay, in various different colours, and one last one. Right, okay, so within this bounded area here, we've got various amounts of dots, and let's just assume for now that those dots are exactly the same size each, although some of them do look bigger and smaller, but we'll just assume that they're exactly the same size for now. And what I'd like to do is find out the fraction of red dots. Okay, so how do we do that? Well, we've got a numerator and a denominator, so I know that my fraction will have this fraction line here, and the numerator says how many of a specific type. Well, clearly the specific type in this case is red dots. So how many red dots are there? So 1, 2, 3, 4, 5 red dots. So that is the amount of a specific type. And denominator says it's the total number of equal parts, but all of these dots are equal, so we've got to count all of these dots now. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 dots in total, but of those 12, 5 are red. Okay, so we'll say that the fraction of red dots is 5 out of a total 12. Okay, so that should help you understand what a fraction actually is. Okay, so without further ado, what we're going to do now is move on. So I'm going to delete that for now, and we're going to start to look at what we call equivalent fractions. So what is an equivalent fraction? Well, it's much easier if we just start an example. So what I'm going to do is draw up an example just here. So I'm going to fill in this part red, this part green, this part red as well, and this part blue. So if I were to say what is the fraction of blue parts, okay, so blue, it would be 1 out of 4. Fraction of shaded blue is 1 out of 4. So 1 is the specific type, and then 4 is the total number, so 1 out of 4. Okay, the red part is 2 out of 4. And then finally, the green part is also 1 out of 4, the same as the blue, because we've got 1 part out of 4 possible total parts. Okay, so let's just take this red bit. If I were to split this, one second, if I were to split this whole shape up into not 4 equal parts, but 16 equal parts. There we go. The shape, the size of the shape hasn't changed, but what we've done now is split it up into further parts. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different parts. Okay, so now what I'm going to do is ask you the same question, which would be, what is the fraction of blue shaded squares? Well, now it's actually 4, but as a numerator, but the denominator is actually 16 because there's 16 equal parts. So how can 1 over 4 be the same as 4 over 16? Well, as we said, the actual size of the shape and the amount of shaded squares hasn't changed. The total amount of the shaded blue hasn't changed because I didn't change the amount of shaded blue, but what I did do is just split it up into further smaller squares. So how is this the same? Well, if you look here, this 1, in order to get to the 4, we need to times it by 4. But if you also look, to get from 4 to 16, we also times it by 4. So clearly, the fractions here represent the same number, because what I could also do is say, well, I want to times this by another 4, and then I'll have 16. But then I can times the bottom part by another 4, and 16 times 4 is 64. So 16 over 64, 4 over 16, and 1 over 4 are all exactly the same fraction. We call them equivalent fractions, okay? So equivalent fractions. And in order to do this, I mean, in a shape, it's nice and easy because we can just kind of split it up. But we can do it mathematically by taking a fraction and timesing it by the same number. But not only timesing, we need to be able to go back the other way as well. So let's say I wanted to say 2 over 4, which was the fraction of the red part. I'm going to take this 2 over 4 and I'm going to divide this by 2, and I'm going to divide this by 2. And what happens here is 2 divided by 2 makes 1, and 4 divided by 2 makes 2. So that makes an equivalent fraction of half, or 1 over 2. Now if we just go to this red bit within the shape, you can see that exactly half of the whole square is shaded red, which, if we were to look at count the actual squares as well, we've got 1, 2, 3, 4, 5, 6, 7, 8 out of a total 16. So 8 out of 16 is also red. But how does this change from this 2 over 4? So we had 2 over 4 to start with, which was before we added these extra lines in this shape. And once we added the lines, it went to 8 over 16. So somehow these two are the same. And if we look at this, to get from 2 to 8, we must times it by 4. And to get from 4 to 16, we also times it by 4. So hopefully you can see that fractions can be changed into other fractions that are equivalent by multiplying or dividing by exactly the same number on the top and the bottom. So what we're going to do now is have a little look. I'm just going to get rid of this. We're going to have a bit of a look at how to change some fractions into other equivalent fractions. First of all, I'm going to write down this, 8 over 12, that's a fraction, and what I want us to be able to do is change it into these equivalent fractions. So 16 over something, also something over 36, 4 over something, and 2 over something. But how do we do this? Well, we'll start off with our original fraction, because we know this has got a numerator and a denominator that we're aware of. But in all of these other ones, we've got these question marks or unknown parts of the fraction, and we need to be able to find out what these are. Now the easiest way of doing this would be to look at, say, the first one. Let's take this blue one here and say, well, how do I get from this to this and then this to this? Well, we don't know how to get from 12 to question mark, and that's an unknown quantity, but we do know how to get from 8 to 16. So how do we get from 8 to 16? Well, we times it by 2. So we're going to do exactly the same here. We're going to times this by 2. So if I just write underneath, I know that 16 over question mark would actually be, the question mark is 12 times 2, which is 24. Okay, so the next equivalent fraction will be something over 36. So how do I get from 8 to question mark? Well, we don't know that because that's an unknown quantity. But we should know how to get from 12 to 36. 36 is in the 12 times table, is actually just times 3. So we're going to times the top by 3 as well. So you see, what we can do is not just have to start with the top or the bottom, we can just calculate either one and then calculate the other one from knowing what this factor of multiplication or sometimes division would be. So this numerator, there we go, 36 on the bottom, the numerator will be 8 times by 3. So this 8 times by that 3 is 24. Okay, so the next one, the same way, we've got a 4 here. How do we get from 8 to 4? Well, this one goes the opposite way, so we're going to divide that by 2, because 8 divided by 2 is 4. So we're also going to divide by 2 here as well. 12 divided by 2 is 6, so it's 4 over 6. And then last but not least, we've got this 2 and question mark. How do we get from 8 to 2? Well, we divide by 4. So this is going to be 2, and then the bottom part is 12, and we're going to divide by 4 as well, so that makes 3. Okay, so equivalent fractions can be timesing or dividing, but we need to do it for both top and the bottom. It's really important to do it for both top and the bottom. Okay. So the next part of fractions of quantities, being able to do equivalent fractions, is a special type of equivalent fraction, and it's called simplifying. Simplifying fractions. Okay, so the significance of simplifying a fraction is that we are going one specific way, which is trying to make the fraction, because let's say if I have 1, 2, and I change it to an equivalent fraction by dividing by 100 both parts, dividing by 100, then what we get, 100 is 1, 2 divided by 100 is 2. So it's 1 over 2, which is half, and that should make sense anyway, because 100 out of 200 is just half of 100 is half of 200. So 1 over 2. The significance of simplifying though, well, this at first is a lot harder to understand than this. We always like small numbers. Small numbers are good because they're simple and they're easy to understand. So we're going to learn how to simplify a fraction, which is trying to divide the fraction both top and bottom by the same number to get the smallest number possible. So here is an example, 21 over 49, and we want to simplify this. So how do we simplify it? Well, we can't divide it by 2. Can we divide it by, you need to ask yourself, can we divide it by 2 or 3 or 4 or 5 or whatever numbers the highest, what's the highest number we can divide into both of these? Well, to do that we need to be able to find what's known as the highest common factor. So the highest common factor between 21 and 49. So the highest common factor of 21 and 49 together. Now we're not going to cover how to find the highest common factor because that's a topic for another video. But if we were to look at 21 and 49 and then calculate what all the factors are, 21, 1, 3, 7, 21, and the factors of 49 are 1, 7, and 49. So quite clearly here, the highest common factor is 7, so we're going to divide by 7. And this means that 7 is the highest number that we can divide into both of these numbers. Okay, so when we divide by 7 at the top, 21 divided by 7 equals 3, and dividing by 7 at the bottom, 49 divided by 7 equals 7. So 21 over 49 simplifies to 3 over 7. So the key thing here to learn is that when you have a fraction and you want to simplify it, you need to find the highest common factor. If you can't find the highest common factor, then try to divide it by a number that you know goes into both of them, because that's clearly a factor anyway, and then try and do it again and again until you feel like you cannot do it anymore, until you can't divide into both of those numbers anymore. And generally when that happens, it will be because one of them is a prime number. Okay, so we're going to try another example for that, another simplifying fractions example, which is 32 over 72. Okay, so we don't know what the highest common factor is just yet. We can calculate it though. Factors of 32 are 1 and 32, 2 and 16, 3 doesn't go, 4 goes into 32 8 times, so 4 and 8, 5 doesn't go, 6 doesn't go, 7 and then 8 we've already done, so that is actually all the factors, 1, 2, 1, 32, 2, 16, 4 and 8. So what about 72? Well, 1 and 72, 2 and 36, 3 does go into 72, see 10, 20, 24 times, 4 goes into 72, and that goes in 18 times, 5 doesn't go, 6 into 72 does go, that goes 12 times, 7, 8, 8 does go 9 times, and 10 doesn't go, 11, and then with 12 we've already done. So these are all the factors. There is another way to find out the highest common factors of 32 and 72, but again we're not going to be looking at that just today. So let's find the highest common factor between these two lists. So 32 doesn't exist, 16 doesn't exist in the other one, 8 is there, and therefore 8 must be the highest common factor. So what we're going to do is divide these by 8. 32 divided by 8 is 4, and 72 divided by 8 is 9. So 32 over 72 makes 4 over 9. As I say, to find out this highest common factor is the key point, and there are various ways of doing it. This way is by far the longest, because we have to kind of think of all the numbers separately. Using a prime factor tree is actually the generally the easiest way if you have a lot of practice. So what about 12 into 144? How do we do that? Well, again, find the highest common factor, and sometimes it's not necessary to draw the list. And if you think about this, 12 is the highest factor that goes into 12, but 144 is 12 times 12, so we know that 144 has a factor of 12, so we can just divide both of these by 12 straight away, and what we get is 1 over 12, because 12 divided by 12 is 1, and 144 divided by 12 is 12. Okay, so that's simplifying fractions, a really good thing to be able to do. The next thing we need to do, and is the last thing on this video's agenda, is be able to compare and order fractions. So what I mean by order is put them in order from highest to lowest or lowest to highest. Okay, so let's have a little think. What is the higher value out of 3 over 5 or 7 over 12? What is higher? At first it's very difficult, and what we're not trying to do here is have a guess, because we're not trying to guess, we're trying to prove mathematically which one is highest. And in order to be able to do this, we need to have the denominators the same. So these numbers here must be the same. So how do we do that? Well, we can times these fractions by anything we want to make an equivalent fraction, so that then they can be compared, so these denominators are the same. So what do I need to times 5 by, and what do I need to times 12 by in order to get them to the same number? Well, clearly if we just times that by 12 and this one by 5, then they'll have the same number at the bottom. And if we try that, 3 over 5, and we're going to times the whole thing by 12, so times by 12 on the top and times by 12 on the bottom. So 3 times 12 is 36, and then 5 times 12 is 60. Okay, so that's an equivalent fraction there of 3 over 5. And then we're going to do 7 over 12. And what we're going to do with this is times both of the numbers by 5. And if you look, if we do the bottom one first, 12 times 5 is exactly the same as 5 times 12, so we're going to get 60, and that's the reason why we can compare the fractions by timesing. It's called cross multiplication. So we just take this 12 and times it to that 5, and then that 5 and times it to that 12, and then we get the same number on the bottom, which is 60 in this case. Then we just times the denominators by the same number. 7 times 5 is 35. Okay, so here we have equivalent fractions, and now we can compare because we've got the same denominator. We're saying that this top one, 3 out of 5, is the same as 36 out of 60, 36 parts out of 60. But 7 over 12 is the same as 35 parts out of 60. So this one is the smaller one, and this one therefore is the bigger one. So we've then compared them, and if we were to write this from, say, smallest to biggest, I would say 7 over 12 and then 3 over 5. So we've ordered them from smallest to biggest by absolutely guaranteeing ourselves that we've done it correctly rather than guessing. Okay, with that being said, we'll do one last question for this video, which would be to order these numbers: 21 over 49, 12 over 21, and then 2 over 7. Okay, so we want to order them from smallest to biggest. Okay, so again, to do that, we're going to need to make this time all of these the same, but instead of just taking all three at once, why don't we try and make 2 of them the same to start off with? So pick any 2, and for this one I'm going to pick these 2. So what I'm going to do is say 12 over 21, and I'm going to times them by the denominator here, this 7. So we're going to times this by 7, and we're going to times this by 21. Okay, so 12 over 21, and we're going to times both the top and the bottom by 7. So 12 times 7 is 84, and then 21 times by 7 is, let's see, 147. Okay, so we've got 84 over 147. Okay, so now we can compare this one to just 2 over 7 over 7, and then we're going to times this by 21 times by 21, and we know that 7 times 21 is 147 because we've just done 21 times 7. It's exactly the same. Okay, so now we need to do 2 times by 21, which is 42. So we've got 42 over 147 and 84 over 147 for these two fractions, but now we need to include this one over here, this 21 over 49. So I've got 21 over 49, but how do I get 49 to 147? What is the factor? Because we want to get this as an equivalent fraction by timesing this 49 by something to get 147, and then 21 by something to get the number that goes here. So what do we do? Well, if you just try 147 on your calculator and divide that by 49, it says it's 3. So 49 goes into 147 3 times, so we just times that by 3 to get 147. And then 21 we're also going to times by 3, and that makes 63. So now we've got 3 equivalent fractions when we started with these 3 ones here with the different denominators. So we can just compare the numerators. So we've got 42, 84 and 63. So 42 is number 1, that's the smallest. 63 is the next biggest, and then 84 is the next biggest. So I've just labelled these 1, 2 and 3 for smallest to biggest. So then what we can do is come over here and say my smallest was 2 over 7, because remember you need to go back to the fraction that was given in the question. We can't use the equivalent fractions to order them. We only use that to find out the equivalent fractions and then compare them. So 2 over 7 was the smallest, then 21 over 49, and then last but not least 12 over 21. So that's how we compare fractions, by putting them into equivalent fractions and then comparing the numerator. Once you've got the equivalent fractions with the same denominator, you then compare the numerator. And that is the end of fractions of quantities. So thanks very much. The same denominator, you then compare the numerator. And that is the end of fractions of quantities. So thanks very much. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah. Would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give it another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.